All right, thank you for the introduction. Like Seth said, my name is Jackie Gaston. I'm an undergraduate at Carnegie Mellon University, and this research is based on work that I did in the summer of 2016 up at the Cooper Lab at Northeastern. So human computation games, or HCGs, have the potential to apply human skill to solving real-world problems by turning them into a game. Some examples of existing games include image labeling and analysis, and scientific problems such as sequence alignment, neuron reconstruction, and protein folding. However, HCGs often suffer from low retention, with much of the work being done by only a small fraction of the users. The mechanics of the game are often dictated by the real-world problem being solved. Is there some way that we can change player behavior and improve retention without having to change the game mechanics? Perhaps we can learn from reward mechanics in popular games. ThreeStar Systems reward players with up to 3 stars depending on their performance of a level. There are common features in many popular games, such as Angry Birds, Candy Crush, and Cut the Rope. But what kind of impact would they have in an HCG? Could they solve our problem with low retention? Based on existing work in the field, we expected that the ThreeStar system could improve retention. Some work has examined other reward systems in HCGs, such as that of Su et al., who found that competition improves engagement, and Go et al., who found that adding points and badges increased self-reported enjoyment. However, we suspected that the ThreeStar system wouldn't appeal to all player types, but only certain ones, such as Bartle's achievers or Tondello's players motivated by achievement. Players may also be motivated by the ThreeStar system as being an example of Halford and Halford's reward of glory. In order to evaluate the impact of game design decisions, we used online experimentation, similar to Lomas and others, to gather data from game players during onboarding. To examine the effect of a ThreeStar system on player behaviors, we introduced one into the existing citizen science game Foldit. In Foldit, players without any biological background can contribute to science by folding gamified proteins, competing for a high score, and working to find an optimal protein structure. There's a set of 31 introductory levels that teach players the game and have been designed to be completed in 1 to 4 moves. Many users who start these introductory levels never finish them, and we wish to find if including a ThreeStar system would impact player behavior and potentially increase user retention in these levels. While the introductory levels have been designed to be completed in only a few moves, we have anecdotally observed that players who take more moves often pursue an incorrect structure, and it may be preferable to restart. So we based our ThreeStar system in Foldit on the number of moves that a player has taken in a level. To determine the ideal number for each level, we had 4 Foldit team members play through and evaluate the levels. Players were rewarded with 3 stars for completing the level in the ideal number of moves, and earned less stars for more moves taken. We integrated our ThreeStar system into 3 locations in the game. First, when a user was playing a level, a test tube was added at the top of the screen to the existing scorebar. This test tube would empty as players took more moves, and the overlaid stars would de-illuminate based on the number of moves taken. Next, we added the number of moves achieved on an attempt to the existing pop-up that displayed their progress. Lastly, we added the highest number of stars earned on each level to the level select screen. We had 3 hypotheses about these ThreeStar systems. First, we hypothesized that the ThreeStar system would cause players to complete levels in fewer moves and take more time per move. This would judge if the users were thinking more thoroughly through their moves, which could help them better succeed on the levels. Second, we hypothesized that the ThreeStar system would encourage players to replay levels that they've already completed. As they try to get more stars per level, they would be practicing with the Foldit tools more, which would be more beneficial in their success. And our last hypothesis was that the ThreeStar system would improve retention. It could create a better experience for the players, which would encourage them to play more levels, spend longer playing the game, and be more likely to return to the game. To test these hypotheses, we created 3 experimental versions of Foldit. The first version was the no-star version. This was the basic game without the 3-star version, and players could complete the level in any number of moves. The second version was the 3-star version, which had the 3-star system as before, but players could still complete the level in any number of moves. And the last version was the ThreeStar R version, which had the ThreeStar system as before, but players were forced to reset the level after the test tube emptied after taking too many moves. To collect data, the game was publicly available for download from Fold.it. New users to the game were randomly assigned to one of the 3 conditions or left out of the experiment. Game log data was recorded from 626 players for a period of roughly 1 week. From this log data, we calculated several different variables. First, the number of extra moves beyond ideal that a player completed a level in. Next, the average time in seconds that a player spent per move. Also, the total number of unique levels completed by a player, and the total time in minutes that a user spent playing a game. We also had 2 Boolean variables. The first indicated whether a user recompleted at least one level at least twice, and the second indicated whether a user exited and returned to the game at least once. For our numerical variables, we performed a Kruskal-Wallis test to check for significance, as well as pairwise post hoc Wilcoxon rank sum tests. For our Boolean variables, we performed a chi-squared test, as well as pairwise post hoc chi-squared tests. All of these use the Bonferroni correction, and more details about the analysis are in the paper. So our first hypothesis was that the ThreeStar system would cause players to complete levels in fewer moves and take more time per move. This hypothesis was supported, as there were significant differences between all 3 conditions in both the number of extra moves taken and the amount of time per move. The ThreeStar system encouraged players to use half of the extra moves, and the addition of the force reset reduced this number even further, which makes sense since it only allows the completion of levels in a few moves beyond ideal. The ThreeStar system also encouraged players to take slightly longer per move, with the forced reset increasing that time further. Our second hypothesis was that the ThreeStar system will encourage players to replay levels that they've already completed, and this hypothesis was supported as well. There was a significant difference in the recompletion rate between the no star and both ThreeStar and ThreeStar R conditions, with the ThreeStar system encouraging players to recomplete levels roughly twice as often. However, there was no significant difference in the recompletion rate with the addition of the forced reset. Our last hypothesis was that the ThreeStar system would improve retention, and this hypothesis was not supported by our data. There's no significant difference in the number of levels completed, the total time that users spent playing the game, or the percentage of users who returned to the game. So to conclude, the ThreeStar system successfully encouraged players to complete levels in fewer moves, take more time per move, and replay completed levels, and thus it was successful in encouraging the incentivized behaviors. Ultimately, though it did not improve retention, ThreeStar systems appear to have some potential in encouraging desired behaviors in human computation games. One especially attractive feature of ThreeStar systems is that they can be orthogonal to other game mechanics, so they can be easily layered on top of an existing game without having to change the existing system. So ThreeStar systems have the potential to be broadly applicable beyond just human computation games. However, further work is needed to determine if ThreeStar systems have a lasting impact on skill. The scope of this research was also fairly narrow, so more research is necessary to explore ThreeStar systems in the context of casual or entertainment games beyond just human computation games. And another interesting path for the future would be to explore the effect of ThreeStar systems on other behaviors, such as encouraging a correct answer. All right, so I'd like to thank my co-author, Seth Cooper, and all the Foldit players. And any questions?
Hi, thanks for the talk. Very interesting. Christian Yoder from Riot Games. So it's kind of too bad that it didn't encourage people to do the game more. Do you have thoughts or conjectures as to mechanisms for getting people to play games that have like kind of societal-wide impact for the future?
Yeah, so one thought about why this ThreeStar system didn't work was perhaps people were getting frustrated with the 3 stars, and so if they only got 1 or 2 stars in a level, they had to work too hard to get the 3-star system. So maybe if we put something in there where it wasn't trying to be the absolute best, maybe a different game mechanic would help improve retention instead.
Hi, I have a somewhat follow-on question. So I was wondering if there's maybe a downside to rewarding number of moves. So I think it's probably positive that people were spending more time thinking about the moves, but I wonder if that might like disincentivize exploration, which could actually be something that helps you learn and get engaged with the game. Did you think about any other like metrics that you might have been able to use for 3 stars?
Yeah, so I definitely agree that there could be some negative aspects to using the number of moves, especially it could encourage people to kind of game the system. Maybe they are trying to use a move that we didn't know would work in that situation or something like that. So maybe doing something else like the total time that a user is playing on the level, because again, these should be able to be completed fairly quickly. Maybe something like that would also improve how well they're thinking about the moves without letting them kind of get around the system.
Mm-hmm. Cool, thank you.